Okay, good morning to all of you. I welcomes to all in our mathematical physics that is belongs to your core 5 paper, and we are discussing Legendre differential equation, and this is our lecture number 36. Lecture number 36. In our last class we have been discussed about for k equal to 0 the recursion relation and corresponding solution of the Legendre differential equation will be this much, that is your y even we are going to be consider because all terms are going to be 0. Detailed we have been discussed in our last lecture, and for k is equal to 1 the recursion relation and corresponding solutions in detail we have been discussed, and we found that a2r value is this much, and the so called odd solution y odd will be this much. We have been detail discussed in our last class. I suggest to all of you that you have to go for that last class video, that is lecture number 35, and we found that general solution of the Legendre differential equation will be in the form of y even b into y odd. Today we are going to discuss about Legendre polynomials. So what we found two solutions. Here we are not considering the coefficient a and b, only we are considering the y even whatever the solution we got, and y odd whatever the solution we got. So we are going to be cross check your y even, that what we found, that is your see y even. I have been written that a0 into 1 minus n into n plus 1 by 2 factorial into x square n into n plus n minus 2 into n plus 1 into n plus 3 by 4 factorial into x to the power 4 plus your general term. You can found in your note itself. This is your a2r term, whatever I written over here. Okay, this is your general term. Up to this is your general term, and then it can be extended. And here I not written that x to the power 6 term, that is your a6. For a is equal 4, a6 I have been not written over here, but you can write these things over here, that it will be how much it will be, minus n into n minus 2 n minus 4 into n plus 1 n plus 3 into n plus 5 divided by 6 factorial into a0. So by taking a0 will be common, then it will be minus n into n minus 2 n minus 4 n plus 1 n plus 3 n plus 4, like this. So here I not written, but in our discussion today I have been written over here. Okay, so likewise y odd you can found we have been got how much. See, here I not consider the a0 term, because a0 with multiplied with something is considered as your this constant. I have been considered only this these terms, y even x terms. Okay, so likewise y odd, how much we found, you just check your note, and you can found that y odd we found this one. Okay, x minus n minus 1 into n plus 2 by 3 factorial into x cube n minus 1 n minus 3 into n plus 2 n plus 4 into x to the power 5 by 5 factorial. Here also I not written x to the power 6 term, that is this one. So, this one n minus 1. See, here one thing I can say you there. See here n minus 1 n minus 3, and next term is n minus 5, and another 2 is increasing, n plus 2 n plus 4 n plus 6, like that, divided by 7 factorial. Okay, but here I written this a6 term. Okay, here means here a6 term, that is x minus, see, I am not considering a0, I am considering from x into x minus n minus 1 plus n plus 2 divided by 3 factorial into x cube n minus 1 into n minus 3 into n plus 2 n plus 4 by 5 factorial into x to the power 5, and minus n minus 1, n minus 3, n minus 5, n plus 2, n plus 4, n plus 6 into x to the power 7 by 7 factorial, and so on. Okay. Now we are going to consider that if n equal to even integer, suppose n equal to even integer, then the solution y even x reduced to an even polynomial of degree n, and y odd remains an infinite series. Okay, you just check by considering one example, n is equal to 4. If we are going to put n equal to 4, you see n equal to 4, then see y even term will be how much? See, y even term will be 1 minus n equal to 4 means it will 4. See, 4 into 5 by 2 factorial into x square, 4 into 5 by 2 factorial into x square. Here it will 4 into 2 into 5 into 4 plus 3, 7. 4 into 2 into 5 into 7 by 4 factorial into x to the power 4. And then next terms will be contain n minus 4 term. So next terms will be 0, right? Next terms will be 0. So I written over 0. So what I written, that if n will be a even integer, then the solution y even x reduced to an even polynomial. So this is a even polynomial of degree n. So here how much I taken n? N equal to 4. So this polynomial having the degree is how much? X to the power 4. Okay. And y odd will be how much? You see, if I am going to consider n equal to 4 for this case, then it will be, we are going to get the infinite series there, because there is no n minus 4 term. See, in this term there is no n minus 4, n minus 4, n minus 4. We are not going to get any type of term or in any term. So hence y odd will be remains an infinite series. Likewise, if we are going to consider n equal to odd, so if n equal to odd integer, then the solution y odd will be how much? It will be reduced to an odd polynomial of degree n, and y even remains an infinite series. We have to check by considering n equal to 5. So you just consider n equal to 5, then what will happen? See, in case of y odd, here we can found a n minus 5 term. So we can get that x minus 5 minus 1, 4 into 7 by 3 factorial into x cube, 4 into 7 by 3 factorial into x cube. Then second term will be 4 into 2 into 5 into 9 by 5 factorial into x to the power 5 plus 0. Why I written 0? Because here the term contains n minus 5, and next term also will be contain n minus 5. So the terms from here whatever the terms we can get, that terms will be contain the n minus 1, n minus 5. So hence all the terms after this term will be 0. So hence I written over here that is 0. Let it is equation number 1, which is a polynomial of order 5, whatever I discussed over here, right? Now then these polynomial solutions, now you can just check if we are going to consider 5, the even remains infinite or not. See, if we are going to consider n equal to 5, that is odd, n equal to 5, then there is no n minus 5 term. See, here, and so on. Whatever the term you are going to be consider, there is no n minus 5 term. So hence the even, y even, it will be a infinite series. Now, these polynomial solutions of Legendre differential equation can be represented of degree n in the form of this one or this one. So these polynomial solutions for n, for different value of n, we can get different value of series, right? So these polynomials can be represented degree n in the form of this one for n equal to even, and yn equal to this one, that is a1 a3 x to the power 3 plus dot 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 up to n a n minus 2 x to the power n minus 2 and dot 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 a n x to the power n for n equal to odd. Here I forgot to write x, you just write x because a1x, because in case of n equal to odd we can found the x minus xq, this is your a1 into x, some coefficient of x, and then a3 x to the power 3, that means minus 4 into 7 by 3 factorial will be considered as a3, like that. So you have to write over x, okay, this is x, a1x and plus a3x2 plus so on, a n minus 2 into x to the power n minus 2 plus a n x to the power n. Okay, now you consider the n equal to 5. N equal to 5 means how many terms we are going to get? 1, 2, 3. So x to the power 5, xq and x. N equal to 5 means you are going to be consider, see, a n x to the power 5, then minus 2, it will be x to the power 3, then minus 2 will be x to the power 1, like that you can consider. And the coefficient of a n are related by the recursion formula, and the recursion formula is nothing but a s plus 2. You just go for your note, that is your recursion formula for k equal to 0. We found a s plus 2 is equal to a s into s minus n into s plus n plus 1 by s plus 2 into s plus 1. So that recursion relation we have to consider over here, a s plus 2. Hence a s will be how much? A s will be s plus 2 into s plus 1 into a s plus 2 whole divided by s minus n into s plus n plus 1 whole divided by s minus n into s plus n plus 1. Let it is equation number 5. This will be used to express a n minus 2, a n minus 4 in terms of coefficient a n of the highest power. How it is, you just see. Now we have to take s is equal to n minus 2. Suppose s is equal to n minus 2, then what will happen? S is equal to n minus 2. See, s is equal to n minus 2 means it will be a n minus 2, right? So a n minus 2 into s is equal to n minus 2. So it will be n minus 2 plus 2. It will be n minus 2 plus 1. It will be n minus 1. It will be n minus 1, right? S is equal to n minus 2. So n minus n got cancelled, it will be minus 2, and it will be s is equal to n minus 2 plus it will be 2n and minus 2 plus 1 minus 1, 2n minus 1 into a n, because here s we are going to consider as n minus 2 will be a n, will be equal to minus n into n minus 1 divided by 2 into 2n minus 1 into a n. Similarly, by considering s is equal to n minus 4, then the equation number 5, this equation number 5, you can check that it will be minus n minus n minus 2 into n minus 3 by 4 into 2n minus 3 into a n minus 2, right? Minus 2, and by solving you can get solving means here a n minus 2 will be this much. You can put over here, then you can found that minus 1 to the power n, this will be minus 1 to the power 2, mistakenly I written n. See here it is minus n minus 2 into n minus 3 whole divided 4 into 2n minus 3, and you have to put, instead of a n minus 2 will be minus n into n minus 1 by 2 into 2n minus 1 a n. So minus and minus, we can write minus 1 to the power 2 and n into n minus 1 into n minus 2 into n minus 3 divided by 2 into 4 into 2n minus 1 2n minus 3 into an, and so on. Here we considered s is equal to n minus 4. Likewise, you can consider n is equal to s is equal to n minus 6. Then you can found other terms also. Now, general term of the coefficients. General term of the coefficients is how much? You can see here 4n minus 4, we got minus 1 to the power 2, right? So a n minus 2r, 2r means it will be minus 1 to the power r, right? Here n minus 4, it is gone up to n minus 3, n minus 3, so it will be n into n minus 1 into n minus 2. It has to be go up to n minus 2r plus 1. Okay, see, you can see that n minus 4 plus 1 will be n minus 3. So hence we can write n minus 2r plus 1 into an whole divided by, it is it is 2 into 4. So hence it can be moved up to 2 into 4 into 6 up to 2r. Here you can see that it is gone up to n minus 4, it is gone up to 2n minus 1, 2n minus 3. So we can write similarly 2n minus 1, 2n minus 3 up to 2n minus 2r plus 1. Okay, let it is equation number your 6. Here r always equal to the integers, that is 1, 2, 3 and so on, but however 2 are always less than that of the n. Okay, now you can see that n into n minus 1, n minus 2 and n minus 3 and up to n minus 2r plus 1 can be written as n factorial divided by n minus 2r factorial. Okay. Okay, you see that this is moved up to n minus 2r plus 1 term. So here I can write n factorial, and if I will divide n minus 2r factorial, then this starts from n minus 2r, n minus 2r minus 1 like that. N minus 2r minus 2. Okay. So here this n factorial will be moved up to how much? N minus 2r plus 1, then n minus 2r, then n minus 2r minus 1 like that. So if I will divide n minus 2r factorial, then it will be cancelled out and we can get this much, right? Then here 2 into 4 into 6 into up to 2r, you can take 2 common, then it will be 2 to the power r into r factorial, right? Next 2n minus 1, 2n minus 3 up to 2n minus 2r plus 1 can be represented by this one, like this. See, here 2n minus 1, 2n minus 3, but 2n minus 2 is not there. I just inserting 2n minus 2 term also. So in the numerator what it will be? It will be 2n into 2n minus 1, 2n minus 2, 2n minus 3, 2n minus 2r plus 2 into 2n minus 2r plus 1 up to 2n minus 2r factorial divided by 2n into 2n minus 2, 2n minus 2r plus 2, 2n minus 2r factorial. So the numerator will be 2n factorial whole divided by, you can see, you can take common 2 in each term, then it will be 2 to the power r, here n into n minus 1 and up to it will be n minus r plus 1, n minus r plus 1 and 2n minus 2r rest is there. Now next we have to go that we can get that it will be 2n factorial whole divided by 2n factorial by whatever I written, this one I just written same in this page because it will be easy for me for the explain. So this much, and then I have multiplied n minus r factorial in the numerator and denominator also, and we found 2n factorial n minus r factorial 2 to the power r into n minus n into n minus 1 up to n minus r plus 1 into n minus r factorial into 2n minus 2r factorial. Then it will be 2n factorial into n minus r factorial whole divided by 2 to the power r into n factorial into 2n minus 2r factorial, right? Then a n minus 2r will be equal to minus 1 to the power r into, in generalized what we can write. So in generalized a n minus 2r, whatever written over here, I just substitute the values. See, minus 1 to the power r, here this much can be written factorial form like this, and this much up to this much can be written as in the factorial form like this one, and this much can be written in the factorial form as this one. We have to just put over there and we can found this one, and systematically I have been written that minus 1 to the r n factorial by n minus 2r factorial into 1 by 2 to the power r into r factorial into 2 to the power r into n factorial into 2n minus 2r factorial divided by 2n factorial into n minus r factorial into an. Let it is equation number your 7. So the required solution yn can be written as, see, the required solution means either this one or this one, both can be represented in the form of this one, that is ynx into an summation over 0 to capital N minus 1 to the power r, this much, okay, into x to the power n minus 2r. This will be the solution. How? You can just check that if we have to consider n is equal to even, then this capital N will be n by 2. That means r will vary from 0 to n by 2. And you just consider this one for the even and you can get this series. And if you are going to consider odd, then if n will be odd, then n, capital N, will be n minus 1 by 2. And if we are going to consider so, then you are going to get this odd series. So considering both these two series, I have been written in general the required solution will be this one, okay, where n, this capital N is your n by 2 if n is even, and capital N will be n minus 1 by 2 if n is odd, right? Now we have to choose for our simplicity. We have been considered that an is equal to 2n factorial by 2 to the power n into n factorial square. Then what will be the equation number 8? The equation number 8. Here an, for our simplicity, we have been considered this one. Then yn, or the so called p subscript n. See, n is here subscript, okay. P subscript n will be r equal 0 to n. You just put, instead of n, you just put over here, and you can found that this ynx will be equal to pnx will be r equal 0 to n minus 1 to the power r 2n minus 2r factorial by 2 to the n r factorial n minus r factorial n minus 2r factorial into x to the power n minus 2r. This is your equation number 9. Here p and x are called as Legendre polynomials. Okay, so in our next class we are going to be discuss about evaluating of Legendre polynomials of order 0, 1, 2, 3, etc. So in this class we have to stop over here. I suggest to all of you that you pause the video and write down the note. If you got any doubt, you can ask me. We are going to discuss. Okay, so thank you so much for watching this video. Thank you.